In this video, we'll discuss the various pieces of equipment on a destroyer. If you find any errors or inaccuracies in the video, feel free to point them out in the bullet points or the comment section. If you think the video is good, don't forget to give a free like. This can help speed up the next video's release. First, let's take a look at the layout of the different equipment on the ship. This will make it easier for everyone to know where each piece of equipment is installed when we discuss it later. The first weapon installed at the bow of the ship is usually the main cannon. Behind the main cannon is the vertical launch system. The structure further back is the ship's bridge. There will be a platform beneath the bridge. Some ships have installed weapons here, such as air defense missiles or small cannons. The upper floors of the bridge are cabins, like the nautical command room. These floors are called Cambridge. The platform on top of the bridge is used to install various antennas. Most ships also have a forward mast on the bridge. The masts on modern ships are used to install various antennas. The number of masts depends on the number of antennas. For example, the Arleigh Burke-class destroyer has only one mast. The Type 45 destroyer has three. Behind the bridge is the smokestack. Behind the smokestack is the rear mast or rear pole. On some ships, the masts and smokestacks are arranged side by side, like on the Horizon and Curve class. Behind the smokestacks and masts is another area where the ship's weapons are stored. Vertical launch systems or slanted launch anti-ship missiles are usually installed in this position. Behind these weapons is the helicopter hangar. Closing weapons are installed on top of the hangar. Some ships have also installed the vertical launch system on top of the hangar. From the smokestack to the hangar, various close-in defense weapons are distributed on both sides. These include chaff launchers, small caliber guns, and auxiliary weapons like close-in weapon systems. Most ships have helicopter flight decks at the stern. The radar is arguably the most important piece of equipment on a destroyer. Radar is necessary for searching for, identifying, and attacking targets in the sea and air. It can be said to be the eyes of the destroyer. Therefore, destroyers are equipped with radars that have various functions. The equipment installed in high places, such as on the upper mast of Cambridge, are various antennas. A large portion of these antennas are used by radars. Various spherical devices installed on ships are also antennas. The spherical part is the radome. The antenna is installed inside. At the stern, an air defense radar is usually installed on a helicopter's rear mast or on a pole. This is also called a long-range warning radar. This radar has a wide detection range, but its function is relatively simple. It doesn't continuously track the target or guide missiles. It's an auxiliary radar. Its function is to search for aerial targets near the ship. If a suspicious target is found, the information will be sent to the main air search radar. The target is then tracked and monitored by the main radar. Therefore, this type of radar does not require high precision. As long as it can spot the aircraft flying in the sky, it doesn't need to identify specific coordinates and the type of aircraft. The detection distance, however, must be long enough. Not all destroyers are equipped with long-range warning radar. The U.S. Navy's Arleigh Burke-class ships and modern Soviet ships are not equipped with them. In the absence of phase array radar, the destroyer is mainly equipped with an air search radar. Early radar and missile technology were not advanced. At that time, destroyers were equipped with two-coordinate radar. It could only detect the target's direction and distance. There was no way to directly measure an aerial target's height. Later, air defense destroyers were replaced with those that could measure the target's direction, distance, and altitude. Three-dimensional radar. The air search radar is usually installed in a relatively high location. For example, at the top of the forward mast. Savarmati-class and Indian Delhi-class frigates and our frigates have a three-dimensional control search radar installed in this position. This is the most advanced radar on the bridge. The performance of this radar is much better than other radars. If the ship is equipped with a long-range warning radar, after the target is discovered, it will be handed over to the other party's radar to track and monitor the target. If a target is considered threatening and needs to be shot down, you then turn on the fire control radar to guide the missile. This process requires a three-cannon radar system. If a warning radar is not installed, then 2 radars are necessary. The phase array radar is a multi-purpose radar. Air defense, search, target tracking and monitoring, and missile guidance can all be completed by the phase array radar. Therefore, there are not many radars installed on ships that use phase array radar. For example, we now have a control and search radar on several pieces, a supermarket drama radar, 3 marine search radars. There are also 9 fire control radars for various weapons. The Arleigh Burke-class shipyard has only 1 Shandong City, 1 sea surface radar, and 3 target indication radars. There are 2 ways to install the same actual radar on destroyers: phase array radars and other equipment. One type is attached to the bridge with 4 large, identical faces. The other is a medium-sized phase array, which is more commonly used in European countries, such as on a Type 45. The dome on top of the destroyer's forward mast is this type. This specific system is relatively small. It's installed with 2 faces back-to-back on top of the mast and rotates when in operation. A spherical radome covers it. While its performance is slightly lower, it's also a multi-purpose radar. So fewer radars are needed on these ships. Although phase array radars are multi-purpose, they still have many blind spots. For example, they struggle with missiles flying at ultra-low altitudes near the ship or non-testing ships. Helicopters are typically used to detect these types of targets, beyond the horizon radar and other systems. Some ships have added various radars to cover these blind spots. Modern ships, as well as the Type 052C and Type 052D, have a dome on top of the Cambridge. The radar installed, there's a high-tech Soviet supermarket radar. Supermarket distance refers to the distance beyond a direct line of sight, where a regular radar cannot see. Because the Earth is spherical, electromagnetic waves can only travel in a straight line. If a target is too far away, the Earth's curvature prevents a regular radar from seeing low-altitude targets or sponges. Beyond the horizon travel can rely on the reflection of short waves from the ionosphere and the atmosphere to detect targets beyond the line of sight. If a ship isn't equipped with a supermarket area radar, what can be done to detect targets outside the city? Simply install a radar on a helicopter. Flying at a high point provides a similar detection effect. The tops of Chinese and Russian ships are typically equipped with a giant radar, like the supermarket radar, but other ships may not be. For example, the sword of the Type 42 destroyer. The fire control tower is on top of the bridge. Anti-ship missiles fly close to the sea's surface when attacking ships, and the radar in this location simply can't see them. Some countries, like the United Kingdom, install a surface search radar on the ship's helicopter to detect low-flying aircraft. The Type 052C also has a search radar installed on top of the forward micromast. This radar can search for ultra-low altitude penetration targets and targets on the sea, and it can provide target indication for weapons like close and defense guns at a greater distance, armament, sonar, and missiles, in addition to the various search radars. The ship also has a gunfire control radar. Missiles are guided differently, so the required radar is also different. For example, several U.S. air defense missiles use semi-active radar guidance. This method requires a transmitter on the ship to send out electromagnetic waves that reflect off the target. The missile then receives this reflected signal to lock onto the target. The Arleigh Burke-class destroyer, for instance, has 3 target illumination radars that look like satellite dishes to guide missiles. The radar installed on top of the bridge or in the middle of the mast is the fire control radar for the rocket cannon. These radars are the primary ones used by ships in combat. Warships are also equipped with navigation radar, weather radar, and other gear. Of course, not all spherical devices on ships are radars. Many are satellite antennas used for communications. There's also a long boom on the mast with different types of communication antennas, like shortwave transmitters and identification equipment, as well as antennas for electronic warfare systems. While destroyers have many air detection systems, they also need detection equipment for the underwater environment. Generally, there are 2 types of sonar on ships. One is the bow sonar, mounted in a spherical housing at the front of the ship. It's used to detect obstacles like mines. Compared to the other type, the detection range is relatively short. The towed array sonar is a very important piece of anti-submarine equipment. When the ship is sailing, it's dragged behind it like a rope. Because it's not installed on the ship itself, it can be larger, and its detection range is also much greater. This array is made up of many small hydrophones distributed in a straight line, evenly spaced within an oil-filled shell. This array has a very long sound wavelength, some reaching thousands of meters, and its detection range is also very far. We've also discussed sonars on ships and those on helicopters, but there's a big difference between these and sonobuoys, missile types and launchers. In the past, destroyers were divided into two types: anti-submarine destroyers and air defense destroyers. Air defense destroyers were equipped with various medium and long-range air defense missiles. Anti-submarine destroyers were equipped with anti-submarine missiles, with torpedoes, depth charges, and anti-submarine helicopters as their primary equipment. To be honest, surface ships' anti-submarine capabilities are quite limited. When a destroyer detects a submarine, the submarine can often already launch torpedoes to attack the destroyer. So, don't be fooled by the size of a surface ship. Its anti-submarine capability is actually not as useful as a helicopter's. Today, modern destroyers are equipped with the same area air defense system. The ship itself is more focused on air defense, and most anti-submarine missions have been reassigned to helicopters. Most newly developed destroyers carry primarily air defense missiles. The Point Defense Air Defense Missile is a point defense weapon. Its mission is similar to anti-aircraft artillery. It's mainly used to deal with low-flying cruise missiles or aircraft close to the ship, since it doesn't travel very far. Its size is relatively small, about the same size as an air-to-air missile. The USC Sparrow Air Defense Missile was developed from an air-to-air missile. There are many ways to guide these missiles. Some use radar guidance, while others use infrared or television guidance. Since it's a defensive weapon and not large, all ships, from aircraft carriers to frigates, will be equipped with point defense air defense missiles. Medium and long-range air defense missiles are the main equipment of air defense destroyers. Most modern destroyers have some degree of area air defense capability, which is achieved with these medium and long-range missiles. They are typically guided using a combination of methods, though the main method is usually radar guidance, which can be active or semi-active. Active radar guidance means the missile itself is equipped with a transmitter. After launch, the missile relies on inertial guidance or a radar from the ship to get close to the target. Then it turns on its own radar to search for and attack the target. These missiles have a long range and are all relatively large. Medium and long-range air defense missiles for land use are so big they're towed on trucks. Their length is about 7 or 8 meters. There's no way to carry many of them on board. This is why in the past, destroyers were specialized as either air defense or anti-submarine ships. Compared to air and anti-ship missiles, rocket-assisted torpedoes have a relatively low police response rate. They also have another name, rocket-assisted torpedoes. Radio command guidance or inertial guidance is typically used to guide the missile to the target sea area. The warhead of the missile is a torpedo or a depth charge. It flies close to the target and then drops into the water. If it's a depth charge, it explodes in the sea. If it's a self-guided torpedo, it searches for and attacks targets like a torpedo. The range of a rocket-assisted torpedo could be tens of kilometers, and its speed is the same as a missile's. It is a long-range diving weapon. It's probably better because the helicopter can return to shallow waters. After finding the target, you can attack it directly. This works better. Compared to other missiles, the rocket-assisted torpedo has not received much attention. Anti-ship missiles are mainly used to attack enemy ships. They're actually an optional weapon on a destroyer. Some medium-sized destroyers may not be equipped with them from the factory, with many being added later. If an anti-ship missile launcher isn't installed, the missile can be hung on a helicopter, which is then used to launch it for long-range attacks, where the ships on board radar can't see far enough. Helicopters are needed to provide mid-course guidance. If a ship is equipped with supermarket radar, that radar can guide the missile to the target after the missile reaches the target area. It turns on its active radar to search for and attack targets. Ships with missiles need both storage and launching equipment. The original launching device was a simple launcher where the missile was hung directly, but the dense smoke at sea made it prone to rust. So the missiles were folded up when not in use. Initially, they were loaded manually, but this was later changed to automatic loading. The missile launchers on some ships are retractable, so they can be stored under the deck when not in use. Today's missiles are launched using launch canisters. The missile is loaded directly into a sealed canister at the factory. For installation, you just fix the canister to a midship mount and fire directly from it. Some vertical launch systems are loaded with missiles, and a launch canister is also inserted along with them. Because aerial targets can appear from all directions, the launcher for an air defense missile can adjust its direction and angle of inclination. An anti-ship missile, however, is fixed. Sometimes, to launch a missile, you also have to adjust the ship's course. For example, if anti-ship missiles are launched at an angle toward the front of the ship and a target is found at the stern, you have to turn the ship to launch the missile. Vertically launched missiles, however, can change their flight direction after launch, which is very convenient. In addition, a vertical launch system has a higher deck area utilization rate, which allows you to carry more missiles. Therefore, the vertical launch system, VLS, is now a more advanced launching method. Although they are all vertical launch systems, there are big differences between the specific types. Today's medium and long-range air defense missiles are basically all vertically launched. Many VLS are designed specifically for one or more types of air defense missiles. This means these vertical launchers can only hold air defense missiles. If other types of missiles are installed on the ship, you have to find another place for them. For example, when the Type 45 destroyer was first put into service, it only carried anti-aircraft missiles. Acqui est tragiceo dos textos para o Ingles Americano. Armament, sonar, and missiles continued. Anti-ship harpoon missiles, launched from a clean fire gun, were added. The Type 052C, after removing the vertical valve key, only has air defense missiles. The anti-ship missile is also installed in a launch tube and fired at a certain time. The most advanced vertical launch system, VLS, is multifunctional. Air defense missiles, anti-submarine missiles, or land attack cruise missiles can all be stored inside. Destroyers equipped with these multi-purpose VLS are also multi-purpose destroyers. They no longer distinguish between air defense and anti-submarine roles. They can defend against air attacks with anti-aircraft missiles and use anti-submarine missiles for anti-submarine warfare, naval guns, torpedoes, and depth charges. Another important weapon on a destroyer is the naval gun. Guns were once the main weapon of warships. After World War II, missile technology developed rapidly, and the development of gun artillery slowed down. However, in subsequent conflicts, people discovered that missiles cannot completely replace guns. For fire support and operations near the coast, naval guns are even more important than missiles. At the same time, naval guns are reloadable and cost-effective. Therefore, they have not been removed from modern ships. With the advancement of new weapons technology, such as electromagnetic guns, naval guns are also receiving more and more attention. Large and medium-sized destroyers are generally equipped with large-caliber main guns. Today, a large-caliber naval main gun refers to a gun with a caliber of more than 100 millimeters. The most common are the 130 millimeters main guns of the Soviet Union and the United States, and the 127 millimeters main guns commonly used in Europe. The 155 millimeters caliber main gun is still in development in various countries, with only a small number in use for trials. There's a big difference between artillery on warships and on land. Because there's more space on the ship, the artillery can be larger and the barrel can be longer. The loading and feeding systems can also be fully automated. This makes the rate of fire and range of a ship's guns much greater than land-based artillery. A single-barrel large-caliber naval gun has a rate of fire of about 30 rounds per minute. This firepower is almost comparable to an Army howitzer battalion. In addition, most naval guns are high-angle dual-purpose, meaning they can also fire at aerial targets. The gun turret you see is actually only a part of the gun system. There's also a feeding system under the turret. If you were to disassemble the turret, you would see a very large automatic loader inside. The shells are stored within the hull and are transported to the turret via an automated shell handling machine, then loaded by the automatic loader. The Type 052C is equipped with two 76mm guns. Artillery with a caliber between 40mm and 100mm is known as medium caliber guns, mainly 100mm, 76mm, and 57mm. The smaller the caliber, the faster the rate of fire. A 100mm gun has a rate of fire of 90 to 100 rounds per minute. A 76mm gun can fire at a maximum rate of 120 rounds per minute. A 57mm gun's rate of fire can reach over 200 rounds per minute. Medium to large caliber guns are usually used as the main guns on ships. Small caliber guns below 40mm are installed as secondary weapons. Many of the small caliber guns on destroyers look a bit like machine guns. Small caliber guns are lightweight, flexible, and have a quick response time. They're also cheaper. They are primarily used to deal with small targets in the water, such as small speedboats and floating mines. Different from standard small caliber guns, the main task of a close-in weapon system, CIWS, is to deal with aerial targets. When firing, it rapidly unleashes a barrage of bullets to defend against aircraft. Therefore, its rate of fire is much higher than that of ordinary artillery. The rate of fire for a phalanx CIWS can reach 3,000 rounds per minute. Torpedoes and depth charges. Missiles and artillery are the weapons on a destroyer that everyone can see at a glance. In addition to these two, destroyers are usually equipped with torpedo launchers. These torpedoes are mounted on the ship's front. Torpedoes have a very short range and are slow compared to missiles and artillery. Therefore, the torpedoes used on destroyers are all anti-submarine torpedoes used to deal with nearby submarines. There's also another very important anti-submarine weapon on the ship, the depth charge. This bomb does not rely on shrapnel to kill the target like ordinary ammunition. It's actually just an explosive wrapped in thin steel plate. It's difficult for depth charges to directly hit underwater targets. Instead, they are set to detonate automatically after sinking to a certain depth in water. The shock wave from the explosion is very powerful in the water. This shock wave is what is used to kill submarines. So when depth charges are launched, many are launched at once, covering the area where the submarine is located to create a damage zone. During the Cold War, the United States, the Soviet Union, and other countries also developed a depth charge that uses a rocket to propel it. There's more than one way to launch depth charges. Initially, they were just rolled off the ship. Later, a launcher gun was added to increase the range. The most common now are multiple rocket launcher style gentlemen bomb launchers. It's like a land-based rocket launcher, using rocket thrust to launch the bomb. This weapon is called a rocket-assisted sonar bar. In the 1960s and 1970s, many countries believed that depth charges lack precision, so the focus shifted to torpedo weapons. The Soviet Union chose to use all-planning torpedoes while developing them. They also continue to develop rocket sonar cables. Now, the Soviet police are equipped with a large number of such weapons. A rocket launcher that looks like a multi-level rocket launcher is considered the iconic equipment of Soviet ships, influenced by the Soviet Union. It can also be seen on Chinese and Indian ships. Propulsion systems and ship classification. Another device on the destroyer that looks like a multi-light rocket launcher is a chaff launcher. Its function, of course, is to launch various chaff bombs to interfere with the guidance of anti-ship missiles. In addition to chaff and electronic jamming systems, there's another way to counter an adversary's anti-ship missiles. However, it is rarely seen because its output rate is very low. This is a corner reflector jammer. This device is a triangular polyhedron that can reflect incoming electromagnetic waves in a circular direction to interfere with radar. It can create a strong radar return with small size and weight, effectively creating a false target to jam radar guidance. This device on warships is usually inflatable. After a missile is detected, it can be thrown onto the surface of the sea and quickly inflated. Therefore, it is also called an inflatable corner reflector or inflatable radar decoy, also known as a rubber decoy. Besides the air threat from anti-ship missiles, Destroyers can also face underwater torpedo threats. So, there's also a lot of jamming equipment on the ship for torpedoes, such as torpedo decoys. Torpedoes are guided by recognizing the sound of a ship's propeller. Torpedo decoys can mimic these sounds to interfere with the torpedo's guidance. At the same time, the ship can also release gas to interfere with torpedoes. This gas creates many bubbles when it enters the water, forming a gas screen to protect the ships. The air bubbles block the transmission of sound waves in the water, so the torpedo can't find its target. Some ships are equipped with underwater bubble generators on the bottom to create bubbles directly. Helicopters are also very important weapons and equipment on warships. Now, almost all major warships have helicopters flying on board. Most ships also have hangars. The main task of a helicopter on a destroyer is anti-submarine warfare. Compared to surface ships, a helicopter's anti-submarine capability is very strong. The aircraft flies fast and is capable of quickly reaching the sea area where a submarine is located. Submarines don't have air defense weapons, so there's usually no way for them to directly attack helicopters. In anti-submarine mode, helicopters attack submarines from one direction. Since the aircraft doesn't touch the water, it won't make noise in the water, and its sonar won't be disturbed, making its work more efficient. It is also difficult for submarines to detect helicopters. Therefore, the helicopter has a very strong stealth capability when in action and can track underwater targets for a long time. In addition to anti-submarine roles, some destroyers carry helicopters equipped with various radars to search for surface targets and help ships detect low-flying anti-ship missiles. Because the radar on the ship has a limited search range for the sea surface, helicopters are sometimes used to provide guidance for anti-ship missiles. They also sometimes carry anti-ship missiles to perform anti-ship missions. Propulsion systems. The power system is a very important component of a warship. There are three types of engines commonly used in warships now: steam turbines, gas turbines, and diesel engines. Steam turbines are large in power and size and are generally used in large surface ships like aircraft carriers. Because the relevant technology didn't exist before, some of our older destroyers also use steam power. Gas turbines are moderate in size and power, mainly used in large and medium-sized ships like destroyers and cruisers. Diesel engines are relatively small in power and size, but they are fuel efficient and have a higher degree of automation in their operating system. They are mainly used in small ships. These engines each have their advantages and are sometimes used in combination. Destroyers will be equipped with gas turbines. The full combustion power plant will install 2 or 4 gas turbines on the ship. There are 2 forms of this. One is to install 2 gas turbines with different power ratings. A smaller one is used when the ship is cruising or sailing at low speed. The other high power unit is the acceleration unit, used for high speed or full speed. Another form is to install 2 or 4 identical gas turbines. One is started when sailing at low speed. When sailing at full speed, 2 or 4 are used in parallel. Another use of gas turbines is in a diesel combined gas power setup. The ship will be equipped with 2 diesel engines and 2 gas turbines. The ship uses a diesel engine for power when sailing at low speed and gas turbines at full speed. Whether it's a steam turbine, gas turbine, or diesel engine, a mechanical gear transmission is required to drive the ship. This approach makes the layout of the ship's power system more complicated, and the power loss is also relatively large. So now there is the electric propulsion system. This method of propulsion uses the engine to generate electricity, and then uses an electric motor to directly drive the propeller to rotate. This approach can greatly simplify the layout of the propulsion system and also reduces noise during sailing. However, the installation of cables for electric propulsion systems is more complicated. The technology is not yet mature. How reliable is it now that the group is in service? Ships using a full electric propulsion system often experience power outages. The system has not yet been used on a large scale.